All right, so in this graph, we're going to look at the graph of cosine function. It's pretty similar to the graph of sine function, except we can think of it as a phase shift, and we'll see how. But before we go there, let's quickly review our properties of the cosine function. And we know again that just like the sine function, your domain for the cosine function is also all real numbers or negative infinity to infinity. Okay. Your range for the cosine function, again, is the same as the range for the sine function, and that was -1 to 1 with the endpoints included. All right. Again, the period of this function was 2 pi. Okay. And the zeros, or the x-intercepts in this case, were all odd multiples of pi, or we could also write them as pi over 2 plus n pi. Okay. The one thing I think we did not see in the sine function, which I will mention here, is cosine is an even function, which means it's symmetric with respect to the y-axis. If you notice carefully, your sine function was symmetrical about the origin. This one is symmetrical about the y-axis. Okay, so we're going to do the same thing we did with sine function, where I'm going to go ahead and make my unit circle and then translate that into a graph. Okay, so if we get our unit circle going here, okay, so here's 0, x-axis, y-axis. And now, so this is my point 1, 0, point 0, 1, -1, 0, and then 0, -1. If you remember, your cosine values were nothing but your x values or x coordinates on your unit circle. Okay, so let's see. The first thing we have here again is we have, okay, the first thing we have is cosine of 0, well, that is 1. So cosine of 0 is 1, which is this value here. Now that's your y value, or basically that's your, right, that's your x value, which means is the distance from the origin. So it's this horizontal distance, which is 1. Okay. For pi over 6, we have √3/2, so that's going to be somewhere around here. Pi over 6 is going to be about √3/2, and that's going to be here. So this is pi over 6. √3/2. Then I have pi over 4 and √2, so it'd be about a little higher than that. So about somewhere around here, you would have pi over 4 and √2/2. And then I have pi over 3.5, which would be, half would be somewhere about here. So this point here would be pi over 3.5. And then finally, this point here, that is 0. Okay. So I'm going to do this side with a red marker. Now when we go to 2 pi over 3, I'm going to be out here. And so then this is going to be, remember this is my, so I have 2 pi over 3 and then -1/2. Remember this distance here, right? This distance is going to be -1/2. That's my distance from the y-axis. Okay. And then if I extend this line over here, I'm going to get pi over 4, or sorry, 3 pi over 4, and then -√2/2. And then finally here, I have 5 pi over 6, and then -1 over, oh sorry, -√3/2. And then finally, I have this point over here, which is -1, right? So I'm going to take these segments, the green are the positive, the red are the negative. I'm going to take these and plot these on our graph. So let's go ahead and make our graph here. Okay. Again, I have from 0 to pi, so I'm just going to go ahead and mark, this is pi over 4, pi over 2, pi over 4, pi over 2, 3 pi over 4, pi, 5 pi over 4, 3 pi over 2, 7 pi over 4, and finally 2 pi, right? So that will give me one full cycle of, or one full period rather, of the cosine function. So we know that cosine of 0 is 1, right? I'm looking at, cosine of 0 is 1. So I'm going to start right up here, which is cosine of 0, and let's say this height here is 1, and say this is -1. Okay, so I'm going to start here. Okay, so that is going to be this one, this segment over here. Okay, right, so this is the value of my angle, and this is the value of my cosine. So there's my green line segment. At pi over 6, which is somewhere around here, I'm going to get root 3 over 2, and root 3 over 2 is going to be somewhere around here. So that's root 3 over 2. At pi over 4, it is root 2 over 2, which is about here. And then at pi over 3, it's going to be somewhere around here. That's 1/2. At pi over 2, it's 0. Okay, now I go negative with 2 pi over 3, and 2 pi over 3 is going to be somewhere around here. And that's going to give me my red segments, right? And that's going to be down about here. Sorry, about here. So roughly that. 3 pi over 4 is going to be negative. It's just a little bit more than that. And then I have pi over 6, 5 pi over 6, which is going to go down a little bit more. And then finally at pi, I have -1. And so that one's going to go all the way down. So now if I look at these, right, it sort of goes something like that. So that's kind of like my one, right? That's my cosine graph of cosine from 0 to pi. And then obviously if I extend that, I'm going to get, we know cosine of 2 pi is 1. And so I'm going to get that. So that is sort of your one cycle for your cosine function, one period of my cosine function. So if I take this, copy and paste, I'm going to keep getting my waveform, which is kind of similar to our sine waveform. All right, so let's go ahead and check this out on Desmos. Okay, so what I've done here, just like with sine, is I've gone ahead and plotted all the values of the standard angles from 0 to 2 pi and their cosine values. Right, so if we graph them, you see that this is giving us pretty much the shape that we saw on the board. Okay, and if I go ahead and draw my cosine function now, well, there you see. So again, the shape of the cosine function is exactly the same as the shape of the sine function, right? Except let's go ahead and compare the two. So I'm going to go ahead and hide these dots here. And I'm going to go ahead and click on my sine. So the purple line here is my sine function, and this orange line here is my cosine function. And we notice that it's exactly the same thing, except there's a shift, right? If you look at it, there's a horizontal shift of about, if I look at sine and I just go ahead and move it a little bit out to the right, then I'm going to get the graph of my cosine function. Okay, and we'll look at that relationship in a little bit, but for now you can think about that the graph of cosine function is the same as the graph of the sine function, shifted to the right by some points.